So today what we're going to be doing is we're going to be adding radicals. Now radicals are fairly easy to add when you have what are known as a common radical. So looking at this, I have 3 root 2 plus 7 root 2. So a common radical means that I have the same number underneath my radical. So to add them, we need to have what are known as common radicals. Just like when we add variables, you need to have like variables, you need to have those things, just like here we need to have common radicals. So when you have a common radical, it's really easy. I know that 3 root 2 plus 7 root 2, all I have to do is add my outside numbers. Because if I have 3 root 2's and I add 7 more root 2's of them, I will have 10 of those root 2's, and that would be my answer there. It works the same way when you subtract them. If I have 6 root 5's and I take away 10 of those root 5's, since I have that common radical there of root 5, I know I can just subtract 6 minus root 10, which gives me negative 4 root 5. And that would be my answer there. So when we have these common radicals like we have right here, the root 5's and the root 2's, it's really, really easy to add and subtract. You just add or subtract like you normally do and make sure you bring along your root 2's because that's what you're adding and subtracting. Now it gets a little bit more complicated when you don't have a common radical. So here I want to do 5 root 8 minus root 18. Now here I have root 8 and root 18. So those are not common radicals. So what I'm going to do is I'm going to force them to be common radicals by simplifying just like we've done the past couple of days. So I'm going to break down that root 8 into being root 4 and root 2. And then I know that becomes then just root 2 and root 2. And then that becomes just normal 2. So I know that root 8 simplifies to become 2 root 2. So that's going to be 5 times 2 root 2 minus, and now I'm going to simplify this 18. So this 18 simplifies into be root 9 times root 2, or that becomes root 3 times root 3. And those two root 3's, when you multiply those together, just become a 3, and that becomes then 3 root 2. So what I've done now is I've simplified these two expressions so that way I could have these common radicals of root 2's. So now let's just finish doing the problem. I'm going to multiply that 5 times that 2 to give me a 10 root 2, and then just bring down my 3 root 2. So now I have the common radicals of my root 2's, and I'm going to subtract them. So I'm going to subtract my 10 minus 3 to give me 7 root 2's. Because I did my 10 root 2 minus my 3 root 2 to give me 7 root 2. Now when I'm doing this, I want to make sure that when I'm simplifying so that way I will end up with this common radical right there. In this case, it happened to be root 2. It can be whatever number it needs to be under there. Okay, so let's look at one more example that's a little bit more difficult. So looking at this example now, I have 3 really big numbers. So what I'm going to do is I'm going to simplify all of them. So I'm going to start over here with the 208. So when I start with the 208, that's going to simplify, and I'm going to say that simplifies to be root 2 times root 104. And then that 104 can break up into being root 2 and root 52. Then that 52 can break up to be root 2 and root 26. And that root 26 breaks root 2 and root 13. And that's as simple as I can make it. So now I have these 4 root 2's. What I'm going to do is I'm going to pair them up, those root 2's and those 2 root 2's. Because I know when I multiply those together, I'm just going to get whole 2's. And that's going to then give me 4 root 13. So I know then that root 208 simplifies to be 4 root 13. Let's do this with the 325. So I know that this simplifies into being root 25 times root 13. And I just did that because I know that there's 13 quarters and $3.25, so I just thought that out loud. And I know that then those two simplify to be root 5 times root 5. That's a 5. And that's as simple as all those can go because I can't break down any of those. But I know that those two, when I multiply those 2 root 5's together, I'm going to get 5 root 13. Okay, so the last one is the 117. Now 117, it's a little bit harder to factor, but I know that breaks up into root 9 times root 13, and that root 9 can break up into be root 3 times root 3, and there's my pair right there that's going to multiply. And when I simplify that, when I multiply it all out, it's going to give me 3 root 13. I'm going to keep my signs the same. I'm going to add them all together. Now let's look. Do I have a common radical? Here I have 4 root 13, 5 root 13, and 3 root 13. So I know that I have my common radical for each one of my terms. So I can just add them all together. And when I add them all together, I do 4 plus 5 plus 3, which gives me 12 root 13s. And there's my final answer right there. So just to kind of go back through this process, I took each one of my terms, because they weren't common radicals, and I broke them all down to be common radicals. And once they were, I just added them all together. Now today, every problem that you have, if they're not already like radicals, they should become like radicals when you simplify them. So sometimes it takes a lot to simplify it. Sometimes you can get lucky and simplify it after the first time. But just depending on the problem, it's going to depend how long it's going to take.